Short, short is the right word. You are live, it says. Hello and very good morning.
Good morning.
Hello, good morning.
Welcome to our webinars and Meet the Experts webinar. This time with a very special guest and a very long partner from us. So I'm super happy to have you guys here on board. Maybe the guests first. We start with a very short introduction and we start with the guy in the bigger picture at the moment. Koen, very good morning.
Good morning, Jörg. Thank you for having us. So my name is Koen. I'm the marketing manager responsible for product management for Raychem heating cables, and I'm based in Belgium. So the setup here is with a unit which we talk about a little bit later in the session today. Thank you.
Yeah, very nice. Great to have you. So let me switch screens.
Well, now I'm on the big screen. Good morning, everybody. Hey, it's great to be here. It's just an honor to be here and presenting, giving us the opportunity to present nVENT as a company and especially the brand, a strong brand name Raychem. During today's session, like I said, my name is Thomas. I'm with the company in the 14th year already. I'm responsible in the sales area for so-called DACH. It's standing for Germany, Austria, and Switzerland. And again, great to be here. Thank you.
Okay, yeah, that's great. Okay, yeah, like I said, it's a pleasure. There's one person missing at the moment. And allow me to send my best wishes to Jemsen. He's always the person who's joining from most far away from our vice president from Singapore. It seems he got the how you say that, the booster vaccine, and he seems to have a little fever. So we send our best wishes that he will be good very soon, and at least after this he's very well protected. And I think in the current situation this is also very important. Okay, what have I forgotten? I have not forgotten to say hello to everyone. It would be great if you could leave your comment to say hello from wherever you are. Thomas, when we arranged this session here, I remember I was standing somewhere at the beach. And I didn't have to wear things like this. I think at the moment we have somewhere in Germany 0 degrees, or it starts to freeze. And I just remembered this morning when I thought, okay, that was a different.
I think it was in Spain, right?
Yeah,
that's true. Yeah.
That's true. So, but actually, for the topic we are going to talk about today, I think the warmer weather is not the perfect surrounding. So, getting colder is for sure, getting more to the points we would like to discuss today. Okay, let's get started because we have a lot on our plate and we have a lot of things to discuss. So first of all, our program for the next year, for the next weeks till the end of the year. The next session will be at the 2nd of December, and the audience, I'm sorry that we had to postpone and shift a little bit our appointments here. Because we had the webinar with SIG last week, due to other appointments, there's just 1 week in between. But the next one will then be at the 2nd of December, and then we have another one also 7 days later, which will be the company Gasmed. I think then we already had the most of the major players in the gas analytical market here in our webinar. And I really hope the preparation is not finished yet, but I really hope that we can have a short Christmas party. But how it's going to look, I have to see. I'm currently working on this. So,
Jörg, why don't you
yeah.
take away the word maybe? And why don't you invite us as well to your Christmas
Oh
party?
yeah, sure. Yeah, absolutely, Koen. You are warmly invited. Yeah. So if you would join, I was thinking of having some outtakes maybe from the different sessions we've recorded. So much,
Okay.
so much material we have. So now you have some pressure to produce some outtakes for the
Very good.
today's session. No, I'm kidding. Yeah, but that's a good idea. Yeah, as usual, we also have the chance, we will record the sessions. The sessions will also be available on YouTube. They will also maybe somewhere available in the nVENT marketing universe, so to say. Yeah, this will also give you the chance to review it if you missed something. Okay, as I said, we have a lot to discuss today. I mean, the first agenda point we nearly already have finished. And so then we will talk about heating cable like the engine of the car. I would like to give some explanation why did I state that, and I would like to give also an introduction why the heating cable and the heating technology, and therefore this long partnership is so important for one of our key and very important products. Then we will have the chance to learn a little bit about nVENT and Raychem. Pretty sure you guys can explain how the different names and the different words play together. I think it's not as complicated as we might think it is. Yeah, and then we get a good overview about the technologies and also newest developments in the field of heating cables. And at the very end, I would really like to show. I've done this in another webinar before, but I think then all of this comes together, especially the aspects of safety, which get more and more relevant when we can introduce our latest PSG ATEX heated sample lines. So this is the agenda and the plan for today. And as usual, please give us your questions. We make sure that the questions will be answered. If we cannot manage to answer the question in the webinar session, and you stated it or you typed it, we will make sure that they get answered later on. So give us your questions, and I think I'm very positive that we might be able to answer them right away. Okay. One overview of the products from AGT-PSG, or more the field of our niche, or the field we are focused in, starts in the gas sampling, meaning the extraction of gas sampling probes. So therefore, we have this huge variety. And whenever I explain our technology and what the company is doing to someone who's not so familiar in this field, I always say it starts with the sampling of the gas, then we have the transportation, and finally we have the conditioning. And I think it's fair to say that the transport here, and this will be the main topic of today, the so-called heated sample lines. I know that there's many names around. Sometimes they call it heated sample lines, heated analyzer lines, but it can also be lines for instrumentation. So then they are sometimes called tubing bundles. So it's different names for this. And I really like to say that this is very often a completely underestimated item. I mean, sampling, everyone understands that the filter technology in gas sampling probes, that this is something which must be kind of complicated. Also with the back purging and the steering and the controlling. For the conditioning system, a gas cooler, the heat exchanger and the cooling circuit itself, very complicated. Everyone would agree. But heated sample lines seem to be so easy, and as I said, one of the key components here is the heating cable, like the engine in a car. So I'm very happy that we have enough time today to discuss this here with our guests, because we don't do that too often, but I feel giving some examples from the real world should help us to understand the difference. And I mean, we are the ones producing not a tubing bundle or a heated sample line like you can see this on the left picture, but it looks very similar. When you look at this from the outside, and this is something we will also find out when we look at the different type of heating cables. From the outside, everything looks maybe comparable. You might see some, like in the picture here, when you see the bending and when you see also the structure and the shape of the jacket itself, you think, okay, maybe that's not a perfect design product, but it still looks okay. But when you look at the right picture here, I think it indicates what problem can occur if you are not using a very, or a product in a very high quality. And therefore, I must show and admit that this year, I think you guys call it the praline box.
Yeah.
What is the name?
Yeah, in English, indeed, or I think in German, Thomas, you had the word Pralinedose.
Pralinenschachtel, right?
Okay.
Yeah. But I call it the chocolate box. I'm from Belgium. Belgium is the country.
Similar, right? Yeah.
Okay. Yeah. So, and that's the reason why in many of our travels and in many discussions we have with our customers, we really bring this, because it just gives. I know we will do this in a more interactive way very soon, but I think it already gives a very nice and good overview of the different type of heaters. And when you really look in the, and I always like to share and to show the details of it, right? Because like I said, if you just look at a heating cable, the different brands, the different qualities from the outside, if you just look at this, might look similar, but when you can touch it and when you see the different layers and this technology, I think that always helps us and our customer finally to choose the right product, because the installation costs, at least in Europe, we have how you say that, a thumb rule kind of. So we estimate that the installation of a heated sample line of a tubing bundle and the costs of this installation can be similar to the investment costs you have in buying this. And therefore, I think it's very important that as soon as you install the product, that it will be reliable. And I don't want to say that already in detail, but that shows that having a very long and quality product, which will, after even a long period of time, be able to contribute a lot of power still, I think that's the right product to choose. Okay, so last slide before my dear colleagues here will give us some more background and will share some more explanation. This is really the two different fields of sample lines we have. So we have on the one hand side the so-called flexible heated sample lines. It's very often that the lines itself are categorized by the jacket of the heated sample line which is used, and then it depends, is it more flexible or is it an extruded version? But the main difference, one of the other difference, maybe the main difference is that in the extruded lines, the heating cables we use, the Raychem heating cables we use, they can be cut to length. Not all of them everywhere, but most of them and most of the ones we are using. So therefore, it is possible to cut them on site. This is a big advantage compared to the so-called flexible lines, where we work with fixed resistant heater. And I think it's for us very interesting to get some more information about how that really works. And therefore, allow me to hand over. So, okay, Koen, are you, who's next now?
It's Thomas is next.
Thomas. There we go.
Can you see the screen? Okay, cool.
Yep.
Yeah, I just wanted to add here where actually Jörg started with, I mean, you brought it to the point, right? I mean, we are in the niche, right? It's always the question, where do we belong to? Is it the piping or is it the insulation part of the contract where we actually belong to? We see it everywhere, right? And it's also depending of a kind of awareness, right? How to deal with this niche product, electrical heat tracing. For the, let's say, kind of the majority, it's just a kind of cable, right? But it's more than that. It's definitely more than that. We are not an EMEAI contractor, pulling some cable for lighting, for instance, but it's very specific and you have to know where to use it. The core, actually, when it comes to this engine of this car, like Jörg just explained, is actually the engineering. It's a heat loss calculation, and he actually brought it to the point. I mean, 10 watt remains 10 watt, right? Or 10 watt is 10 watts, but the detail is in the devil, like it calls to say. I mean, after a certain period of time, we still hope, and everybody wants to have the kind of retention of having 10 watts. We will come to this any later. When it comes to this niche product, you don't want to spend some efforts, time, and money in, finding the fault, which is accompanied with some dismantling costs, new installation, right? Who is the guilty one? It's always like this, right? So it's quite important to understand what is really heat tracing about.
Oh yeah, and Thomas, let me pick up on this example because I really like it. I mean, when you see, I have to show it bigger, maybe a little bit later. But when you see the integration of the heating cable in our tubing bundle, for us, it's super important that we have the same heat everywhere, because from a technical point of view, okay, we have some lines where it's freeze protection, but we have also lines with holding temperatures 120, 150 degrees C. And only if there's one cold spot, it's enough to cause condensate. Right. So, I mean, in our dimension, maybe that's also interesting to say, the tube dimension we have here is compared to the tubes, the pipes you guys equip, it's like playing in the dimension. But still, the task itself is maybe even more important. So I completely understand what you are saying, Thomas. Yeah.
Okay. Let me see how this works here, actually.
Sorry.
Okay, Raychem. Just allow me to give you a quick overview. nVENT is actually a new company, right? There was a spin-off in May 2018. We have a kind of history, which I'm going to explain in later. But just talk about nVENT. We are divided in 3 segments, which you can see on the bottom. This is enclosure. This is some kind of floor standing or wall mounted enclosures, terminal boxes, as you can see in some pictures, with very strong key brands called Hoffmann and Schroff. We can be seen as a competitive in the industrial market with Ritter. Very strong in North American market compared to Ritter being the leader in the industrial area in Germany, for instance, right? On the right-hand side, it's the Fastening Solution. This is all about, fixing material, installation things like a cable tray, installation tools for HVAC, fixing materials, like I just said, for piping, like for instance, some clamps and so on. In the middle, it's us actually, Koen and I, representing the right part, industrial heat tracing solution. We are divided in actually two business or two segments, which is BIS, building and infrastructure solution, and IHS, where Koen and I belong to the latter one. With this kind of three segments, we are also following a kind of mission, which you can see on the top. We believe that safer systems ensure a more secure world, and everything is going to electrifying. I think we are going to be well positioned with this kind of mission to be followed. We try and actually we do connect and protect our customers with inventive electrical solutions, like Jörg just mentioned, and we will come to this point any later. From a revenue point of view, it's $2 billion, and we are engaged with almost 9,000 employees.
Okay, that same sounds like PSG. Comparable.
Well, comparable. Like I just said, we are still a relatively new company with the name nVENT, but under the name nVENT, but we have decades of experiences, successfully executed projects and services under the brand name Raychem, which you can see on the bottom.
That's very impressive, yeah.
Let's focus on that one. What is actually electrical heat tracing about? You just name it, right? It's getting cold. I still have my light on because it's winter time just starting, right? But it's not only freeze protection, right? I mean, the difference we see in Germany, for instance, is 50-50, so to say, half-half, winterization and maintain process temperature. It's changed where, depending on the region you are active in, engaged in. For instance, in Russia, where it's colder, you have more freeze protection application against maintained process temperature. When you go, for instance, to the Middle East, where you have the long sulfur pipelines, there the ratio is, let's say, 20-80, roughly. So we still are very engaged even in summertime. There's the investments going on from end users company. We are very much engaged with the chemical and petrochemical market, and there is actually the mix coming from, right?
But Thomas, I think that's also an interesting point, because sometimes we have the discussion when we talk about our probes. You know, they are installed in very high platforms at the stacks, for example, to measure the emission. And I think sometimes it's quite interesting because the people underestimate the temperatures we could even reach here in Germany or Belgium, right? So I think sometimes, especially when you calculate, and you already mentioned this, that the heat loss calculation, meaning how much power do I have to put in to maintain a certain temperature, that this calculation is very important, that you have the right experience and knowledge. What is the ambient temp? What can the ambient temperature be, right? Because that's a major impact, so to say.
Well, this is actually what we're doing, right? We are compensating the heat loss between the minimum ambient temperature and the maximum, right? So this is actually the ones we are focusing on. Yes, and you're right. There are some applications which are just very sensitive, right? It's, for instance, to protect the critical processes. Thinking about the example I gave before, for instance, sulfur. The temperature window is very narrow, right? If you are too hot, it's going to be damaging, or it can just destroy the product itself. If you think, for instance, the chocolate, right? If it's too cold, there's too high viscosity. You can't, there's no flow. If it's too hot, it's going to be change the characteristic of the chocolate itself. It get a different color, and you can't use it anymore, right? So it's always you have to know many things in order to select the right type of cable, right? When it comes to enhanced productivity, this was my example about the chocolate, for instance, right? Viscosity, reduce energy is actually we do it with to apply our self-regulating heating cable, which we will discuss any later more in detail, and increase safety and comfort of people. I mean, think about, right? In regions in both BIA as building and infrastructure solution, as well in the industrial solution area, we do have application, for instance, gutter de-icing, snow melting, ramp heating, where you don't want to fall down and you don't want to get a kind of incident from your people, right? There's also kind of application. It's not only for the BIS sites, the house builders, right? Ramp heating, you are as well protected, and you don't have to move the snow in the morning after snowfall. It's also in the industrial environment, quite common.
Yeah. Okay. Yeah. Thank you for explaining this.
So just to give you, I personally like these pictures because picture tells a story, right? What actually happens if heat tracing application fails, right? I mean, you can see it on the picture yourself, right? If something blocks, I mean, just think about a production loss or a shutdown of a plant just because the selection of the wrong heating cable with the wrong power output. What kind of impact and consequences in schedule and cost could it have, right? I mean, a pipe like you see here on the right-hand side, this is a kind of fatty oil, right? It just stuck. It's stuck in the pipeline, and you can even warm it up, heat it up to increase or to change the viscosity to get it float, right? Otherwise, you have to cut the lengths. And think about, right, when it comes to the environmental damages, you have to dismantle the insulation, you have to recycle it. I mean, it's just some underestimated issues you were just referring to in the beginning. Just think about the consequences which could actually happen. Sometimes we see electrical heat tracing as a kind of insurance, right? We have some application and some projects where the need for the electrical heat tracing system never applied. But in case of, right, in case of you have it installed and you have, for instance, winterization at 5 degrees and it's switched on, then you are a happy guy having thought about electrical installation, right, or electrical heat tracing installation.
Yeah, I understand.
Raychem, we are still proud to be the representative of Raychem, which is looking on a long history. And we changed the names in between. I will come to that one later during this kind of timeline you can see here. Actually, Raychem consists of the word radiation chemistry. There was a very smart young chemist, Paul Cook, who actually was engaged with this field of chemistry, radiation chemistry. We will see a video how actually self-regulating heating cable works any later. Actually go through quickly. 10 years later, he actually founded Raychem, like I said, based on the words radiation chemistry. And already in 3 years later, in 60s, 70s, actually 60, he invents some heat shrinks, tubing, and polymer X-link products. Right? It was actually started with the ski, and he was thinking, how can I better improve the flow of the ski, or the over the snow. He was thinking about some special polymers to be used here. Okay. Raychem itself, as a self-regulating heating technology, was born in 72. So think about on the right, it's here already popping up 50-year celebration, most probably to be expected next year, right?
But see again, there's nearly a similarity. We were founded in 75, so we nearly made it to the same size.
So maybe we can do something together, right? A big party.
but Thomas, I mean, in the preparation we said, and it would be very interesting, since when we are using Raychem products. And I must admit, I mean, we are working in 75, PSG was founded. And since the early 80s, we started working in the tubing bundle section. And ever since, for the self-regulating applications, we use the Raychem heater. I really think it's a super long...
There must be a reason behind it.
Yeah, honestly, yeah, for sure.
Okay, just quickly go through 80, 90, while there was some portfolio expansion here and there, right? Leak detection, you can see skin effect technology for long piping distances. We see it quite a lot in the Middle East. Around 2000, there was this acquisition. At this time, we've been Tyco, right? Tyco was a very big company. They did a lot of acquisitions. You see here, for instance, Pyrotonax, which was a brand name for the mineral insulating heating cable for higher temperature application up to 750 degrees. This was Pyrotonax. During the Tyco days, we had a lot of brand names, and that's actually where the confusion comes from. Being Tyco, then we actually became Pentair. There was a merger with Pentair, and finally with nVENT, spun off in 2018. So for us, it's quite important to be Raychem, to be seen as Raychem.
Yeah.
This is the most important one. In 2003, it's just to close this kind of timeline, we were also adding some serial heating cables with the PTF sandwich technology. This was actually completing our product portfolio. In 2016, we followed the market demands. We invented some low smoke, zero halogen polymers for self-regulating heating cables. It's mostly seen in the BIS environment, right? And this year, actually, when starting from the beginning back, it's 75 years that we are engaged with whatever kind of polymer sciences. We have a lot of scientists just being engaged about the polymer. I mean, the polymer is the key, right? To make sure that we have the high power retention technology. And this was actually our latest invention, where we are very proud of that we invented, or we selected a polymer which is able to retain the power output, not only about the warranty period, but also much beyond, right? Much above. We are talking about 20, 30 years retention warranty, or retention of the power output. Koen will talk about it later in more detail.
Wow. Okay. Yeah, I'm excited to hear about that. Great. So now you want me to start the video, is it?
Yeah, just give us a moment. It's a 1-minute video only. It's also quite impressive to see where we come from. We have a lot of patents, and our colleague from the US leading actually the product business is giving some words around this.
Okay.
I'm extremely proud of the team involved in this innovation and in bringing this breakthrough product to market. It hasn't been easy, and it's taken years of science and diligence. I'm also personally proud of what this represents in the continuing legacy of Raychem, the company and now the brand. Raychem is recognized as the founding company of radiation chemistry. Paul Cook, a co-founder of Raychem back in 1957, began experimenting in polymer science. That's almost 75 years ago. And now, almost 50 years ago, he subsequently invented self-regulating electric heating. He went on, of course, to develop those technologies into the commercial and industrial applications we're familiar with today. We have come so far since then, and this product, Raychem HTV, represents a major advance again in this field of knowledge.
Wow. I think that's the one we will hear a little bit more details about, right?
Yeah, exactly.
Yeah.
Great. Okay, so thank you very much, Thomas, for giving us this wrap up about learning more about nVENT and Raychem, nVENT the company, Raychem the brand. Now, Koen, it's your turn, isn't it?
Yes, sir. Yeah, show me the next slides. I'm just gonna, I think I have a few slides, and then I'll demo something here behind me.
Yeah, that's great.
Yeah, so here what you see on this slide deck on the left side, a few pictures of our heating cables. Not only self-regulating heaters, we also have constant wattage heaters, We have series heaters, we have metal shielded heaters with mineral insulation. So on the right side, you see the complete portfolio. On the horizontal axis there, it is the maximum continuous operating temperature. And yes, a lot happens for freeze protection, but we go all along to 500, 550 degrees Celsius. Think about incinerators, think about asphalt. Those temperatures, process maintained temperatures are above 130, 150 degrees Celsius, right? So on the vertical axis, you see the maximum intermittent exposure. So as Thomas explained, a heating cable is sometimes just needed for freeze protection, but it will go along with a tubing bundle, which transports 200 degrees Celsius gas.
Right.
And then the heating cable is not doing a job of heating the gas. It is just sitting there waiting for the process to fail and then to maintain the temperature. But it also needs to make sure that the heating cable can see this temperature of your tubing bundle. Because if it's 200 degrees, your gas, you should not damage my heating cable, right?
Yeah.
So we have an operating temperature and we have an intermittent exposure temperature. You have all kinds of products. The majority is self-regulating technology. And why is that? It fits perfectly between the 0 or the 5 degrees Celsius and the 200 degrees Celsius, where the main applications are. But moreover, customers love self-regulating heaters. It was founded in 1972 and it really revolutionized the world. Before that, like constant wattage heaters, we have a Pyrotenax brand, a legacy brand. This was founded in 1937. Right? But there was issues mainly because of overheating and risk of explosion. Okay, in 1972, when the self-regulating heating cable came, this was kind of an intrinsic safe heater. You can, on a valve, you can overlap a self-regulating heater, and on the crossing point where the heater heats the other heater, if you wish, a self-regulating heater will feel the temperature of the surroundings and it will reduce its power automatically. So
Yeah,
this is kind of a magic heater.
Yeah, I must admit, when I first came into this industry, this is something I thought, hey, that must be a very, that's a game-changing development, right?
Yeah, it's not a metallic heating element. It's not a copper line which is heating. It is, we call it a semiconductive polymer. It is a mix of polymer and carbon black, right? And depending on the temperature, we have a different form.
Is it? We have that explanation in the video also.
Yes, you can show me the video. That's actually a good.
Maybe let's put it.
Yeah, right.
Raychem self-regulating heating cables automatically adjust their power output to compensate for temperature changes. The outer jacket, braid, and inner jacket provide mechanical, chemical, and electrical protection. But the magic happens in the conductive core that surrounds the two parallel conductors. As the ambient temperature drops, the core contracts microscopically, and the number of electrical paths through the core increases. More heat is produced. Conversely, as the ambient temperature rises, the core expands and has fewer electrical paths. Less heat is produced. At a certain temperature, almost all electrical paths are disrupted and power output is close to zero. A self-regulating heating cable adjusts its power output along its entire length. That's what makes it a safe and reliable solution for many applications.
All right, thank you. Exactly, that explains it better than I do. So you can just move on to the next slide there.
No, I didn't want to say it explains it better, but I think this animation is pretty nice.
Great.
And allow me a short interruption here, Koen, because again, for the tubing bundle, this is a very, very important characteristic and solution. Why? Often we see the situation that tubing bundles are installed inside a plant in very, very long lengths, because depending on the sampling point, depending on the measuring point, we have to come from a certain sampling point to the analyzer environment. It's often an analyzer cabinet or an analyzer house, a full container. And then we have the situation that in this container, it's air conditioned. So we make sure, because especially the analyzer, they don't like so much temperature drop, or they cannot stand freeze or something. And then we have the situation that outside it could be minus 10 degrees, just as an example, and inside we have the perfect 18 degrees C. So where are you putting your PT100? Where are you putting your temperature sensor, and how are you going to control this? So whenever it comes to temperature ranges, especially from the temperature holding or maintaining temperature, what you mentioned, Koen, and Thomas, in the heat loss, whenever we can manage to use the self-regulating cable, I must really say we are happy, because then the regulation, the temperature controlling itself, is done by the heating cables.
Exactly. That same heater can provide 10 watts per meter outside,
Yeah.
and only 6 watts per meter inside on that same cable. So that's this fantastic regulation. On the slide deck, you see actually kind of a digital twin of what I have behind as the demo panel. So on your left side here, I don't know if this is the left side or the right side.
Yeah.
Right.
It's our left.
This is your left, okay.
Yeah.
Maybe I put you on solo layout, Koen, or on the bigger layout, so that we can better see you, right?
Yeah. So here you have the field, which is typically hazardous area. Okay, so there is risk for explosions. There are certain pipes that need to be heated, and you see here the heating cable. This is a red color heating cable. Here we have a different one. It's a black color heating cable. This is a metallic pipe. This is a plastic pipe. And then you come in with the power cable. Okay, you need to power this up to 30 volts, 400 volts, whatever. This goes into a controller, or it goes into a more simple thermostat, or it just goes into a junction box with a light. Okay. So we have all kinds of solutions. This is the more advanced solution. I don't know if you see this here, 37 degrees Celsius, it says.
It's hard to see, but we trust you.
Okay. So then out of this controller, you have the heating cable, which comes along the pipe. It is typically installed underneath, more or less, because heat goes up. And then this gets insulated. And this pipe may be 20 meters, 50, 100, 200 meters. And then it ends somewhere with an end seal. And in this case, this is a lighted end seal. So you may have seen this already switching on and off, depending on the set point, because there is the sensor here as well on the pipe. So the sensor takes the temperature. Inside the controller, you can put your set points. When the heater needs to start heating up, this will work, and this will become a green LED. So this is the field, if you wish. Then it starts to communicate or to connect everything into your panel. So you have a power distribution panel or a power distribution building where you have all the circuit breakers, controllers, and then this would be one of the screens. And now you see this one is going on, right? So now this needs to be the pipe again. So this goes automatically. And at the same time, I have my 3 lines, and I can play and see what are the warnings, the trendings, the history. So this is perfect for preventative maintenance activities, scheduled maintenance activities. And if something is wrong, you will get a warning before you get the failure.
Okay.
Or something which we call self-testing. In summertime, it's not freezing, so you don't need the heat tracing cable, but every month we're gonna check for 20 minutes if it's working. So we have an automatic check. And then from here, if the customer likes, he can go to this process control room. So we can connect into his DCS system, and we can say, hello, there is an alarm on circuit or tubing bundle 23, there may be an issue, all right? So this is kind of the entire system. It's not just the heating cable. It is heating cable, components, controllers. It's a full system, right? Everything is ATEX certified, ICX certified. So we take care of all these certificates.
Okay.
Right? I hope this was more or less clear.
Well, no, that was a great overview, but maybe just that we make this very clear for the audience. So first of all, you said there's a temperature controller, which is not needed if it's a self-regulating cable. It's not mandatory, so to say, right?
Yes, so you can have simple systems without thermostats, but I would say the advantage of a thermostat, definitely when you go to APAC, to our friends from Asia Pacific, it is not freezing a long time. So if you have a winterization system in China, right, maybe you may have a freezing risk 10 days per year, 20 days per year, or 10 nights only.
Yeah.
So yes, the self-regulating heater can reduce energy, but still it is better to have a very economical thermostat, which just switches off the self-regulating heater for 320 days per year. So in the freeze protection area, no need, but a basic thermostat will help you reducing your energy costs, maybe 80%, 90%.
Understand.
And on the more complex area, we are talking phenol, we're talking sulfur, we're talking asphalt, we're talking polymer, liquid, chemicals, gas. Then you definitely require a controller because you have a very narrow temperature band. And it is very critical not to damage the liquid inside and to have a production loss of even 1 day, right?
Yeah. No, I understand. Okay, thank you for clarifying this, Koen. It's just, important to say, because we also have some easy installations, if I may call it like this, right? It's the tubing bundle. And I mean, this is the beauty of the self-regulating, that you don't need to take care of any temperature control of this. I understand from
safety, the nice thing is these self-regulating cables, they have their own T rating, temperature rating. So yes, they are safe. From safety aspect, you don't really need the controller. Imagine if your controller breaks down,
right?
A constant wattage cable would create a risk of explosion. Here, in this cable, there is a maximum. This T rating is T3, this one is T6. T6 means it will never go above 85 degrees Celsius, even without controller. So for safety point of view, there is no need for controllers on the self-reg. That's one of the main beauties of self-regulating.
Yeah. No. Okay. Thank you for clarifying this. Yeah. Okay. Now let's get back to
the slides. I have a few slides.
Sure. There we are.
Next one. So I want to take the opportunity, maybe another 3-4 minutes here, go quickly through this one to introduce the newest self-regulating heater that we have launched earlier this year. It is the nVENT Raychem HTV. And HTV, as you can see there, it goes on the horizontal axis to 205 degrees Celsius and on the vertical axis to 260 degrees Celsius. This is, if you wish, our new flagship product. It is the highest temperature self-regulating heater. If you go to higher temperatures, you switch to a different technology. Now, the main innovation here, and you see the 3 logos. I have 3 slides, 1 slide per logo that I will explain. So the first logo on the left side has to do with the power retention, the second logo with the warranty, the third logo with the design life. So you can switch to the next slide. The first logo, what does it mean? It talks about high power retention, and it gives the figure 95% power retention after 10 years at 205 degrees Celsius. So that's, let's say, a disadvantage of self-regulating heaters. If you compare 2 heaters, one heater can be 10 watts per meter when you purchase it. The other one can be 10 watts per meter when you purchase it. But after 2 years, one can go to 5 watts per meter. and you may have big issues. So power retention, because the fact that it's a carbon mixed polymer heating element, there is some chemical oxidation happening and there is a certain life. Okay. And Raychem heaters have always had a long life, and now we are quantifying this so our customers can clearly see what they're getting. And after 10 years, there's a minimum of 95% in the worst case conditions. So a 10 watts per meter heater is still 9.5 watts per meter after 10 years. Okay, so that's this first logo. Moving to the second logo is the 30 years design life. Okay, sometimes we have clients and they are making a new plant, industrial plant, and they say, okay, we're designing for 20 years. Can you provide a product which lives 20 years? Okay, so how to answer this? First of all, there is no common definition in the market for self-regulating heaters. I can say, yes, 100 years, but it depends on the power retention.
Sure.
How much power do you want, right? So there's no international standard looking at this, and therefore Raychem has always had their own definition. And the definition is on the slide there. We have a design life of 20 years or more when powered on continuously, based on 75% power retention after 20 years. Mm-hmm. Now, most of our applications are not powered on continuously. That's why we say 20 years and a plus. Okay, so it could be longer than 20 years. Now, our latest innovation, the HTV, has an innovative heating core with new polymer materials and nanotechnology, and therefore we managed to increase the bar to 30 years or more. Okay, so that's the second logo. And then if you move to the third one, that is the 10 years warranty. That is something that we have on all the Raychem products, on all our heating cables. So what do we provide to our clients? It's typically, the standard is 2 years product warranty when you purchase. But on any of our heating cables and components, we can move this to 10 years because we are so sure and we want to give the customer a peace of mind. Okay, so
and I think, Koen, let me jump in here for a short second, because honestly, when we look at our quality cases, our issues we had with your product, and I wouldn't say it if this is not the case, and I think our deep cooperation wouldn't exist for so long, we just didn't have any. I mean, sometimes you are in discussion with EPCs or with other customers, and they say, "Okay, I need an extended warranty," like you said, and I think that's and we take advantage of your strong commitment to the quality with this 10-year warranty program, because this is also something we can then finally offer our customer. And I think that's this initiatives really also to the outside really confirms and shows where the position is, right?
Yeah. When we look at our quality issues that we are getting back from the field, what is it typically? In the past, we always said you install Raychem and you forget, right? Yeah. You install it, there is insulation, nobody sees the cable, it is doing its work, but everybody forgets about it. Yeah. And then one day somebody comes in, an operator, and he needs to attach something on his pipe. So what does he do? He has the cladding, he takes a screwdriver, and he goes through it to attach a label or a tag or something. And then with the screwdriver, he goes through the cable. Yeah. These are the typical things that we may have seen when it comes to quality issues.
Yeah, that's right. That's right.
Yeah, it's the first question actually, right? When we get a kind of claim, the first question is from us, who was working on the pipe the last days, or actually, and then you will figure out very quickly. Okay, point. Yeah.
Okay, good. Yeah, I think we have to a little bit have the clock in mind. It's only 6 minutes left. So, but Koen, I think that was very impressive. And allow me here to pick up one item or one thing you just mentioned in a short sentence, and this is the ATEX situation. I mean, we know that safety, I think it was, but it even becoming more and more important in this type of applications. And if we remember the picture from the beginning, I think we will understand what can happen with an item like a heated sample line or a heating cable if this is not a quality one. I'm very happy, and I think that's a big innovation. You shared the HTV cable and the HTV innovation with us, and obviously this will also be available in our tubing bundles. At the same time, I would like to show here our latest developments, and this is something I'm very proud of, because we managed to get a full certificate for an extruded heated sample line, and this is something which is not existing in the market so far. The advantage for the end user really is before. I mean, when we look at the heating cable, it has an ATEX certification or an ATEX certificate. And so the so-called, maybe the standard ATEX line, how we have manufactured them many years, was with a Raychem heater. And if the customer needed an ATEX approval, we would share.
I need to walk around, sorry.
Yeah, no worries. No worries.
Otherwise my lights go off here.
Okay.
In the office.
You have to be more active, Koen.
Jumping around.
That's funny though. This is for the outtakes for the Christmas party. Okay. No, but anyway, what I wanted to say is we would deliver the ATEX certificate for the heater. And then we understood that nowadays it's also other components are really looked at. I mean, if you look at your junction box, this is always my favorite example, Koen. If the junction box is ATEX certified, it is made from conductive material. Because otherwise you could create electrostatical load just by, passing by or just by the winds. There's many by cleaning. So there could be already a spark which could be responsible for an explosion. And therefore, we invented these two new heated sample lines. The one line is the AX2. This has a special technology here with a conductive aluminium underneath the jacket. And finally, we also developed the so-called AX3 line. And the AX3 line is with a conductive jacket. So maybe you saw this in one of the other webinars where we've been measuring the electrical flow. And when you do the installation, you get the Raychem heater. I think in this case, it's an XTV self-regulating heating cable. You ground the inside, meaning the process tube, and the outside jacket. And with this, we can make sure that there will be no dangerous electrostatical load. And this is also proven by a certificate. So even if you short the line on site to the required length, I mean, you always have to do, especially you have to follow the instructions from nVENT. You will receive the instructions how to shorten the self-regulating cable and what is required there. And from us, you get the instructions how you can cut and configure the heated sample line at the very end. But then you have a full certificate, and this is a big difference. And I would say also a big innovation, which helps to make the industry in this field even safer. Okay, last one, and again, we are running out of time. It's kind of crazy. It's really this innovation. As you can see here, it's also with a Raychem heater. And what we managed to do there is, so far you always had to decide, am I taking an extruded line, very robust, from the jacket, or am I taking a flexible line? The flexible line has a smaller bending radius, but the jacket is not as robust. And sometimes when you install it, you might have some damages. And this is another innovation is really this, we call it the extruded flex line. And with the extruded flex line, we have an extruded line, super robust jacket, and at the same time, a super high flexibility. I know you guys, I'm just showing this here, these lines are always fixed installed. I know that the heating cables don't like to be moved a lot. So, but this really allows us, I think I included, just one picture here, as you can see in an analyzer cabinet,
In the cable
analyzer
tray.
house, on a cable tray. And this on the right picture, on the bottom, you see a standard extruded line, and then you have the extruded flex line. So I think it's quite convincing, and it's also money saving, right? Because if you need not so high bending radius, you can. It's easier in the installation, and I would say the better solution there. Okay. So again, we missed the Q&A session, which is kind of a pity, but we are going to look into the questions who occurred here after the meeting for sure. Allow me to thank you guys, Koen and Thomas, very much for being our guest. I think it was super interesting for me. Even I learned again new things. I mean, we have this partnership for so long, but still there's a lot of knowledge to share, and I'm very happy about the partnership we have. And I wish you guys then all the best.
Thank you for giving us the opportunity, and it was great. Actually, we could talk about hours about this topic, but the time is just flying. And thanks again. Great session. Appreciate it very much.
See you at the Christmas party.
Yeah.
See you, Koen. Great idea.
Wow.
Take care, guys. Bye-bye.